AICTE Adult Sponsored Faculty Development Program for this afternoon session. Before diving in today's conference, let us have a quick revisit on previously gained knowledge. In this morning session of Day 4, Mr. Raghavendran delivered an insightful talk on V2G power transfer technology. The session highlighted the V2G enables bidirectional power flow between EVs and the grid. EVs function as energy storage system, providing grid support service. It helps in frequency regulation, voltage control, and peak load management. Operation is achieved using bidirectional converters and smart grid communication. Session 8. In the afternoon session of Day 4, Mr. Arun Kumar delivered an engaging session on electric vehicle charging infrastructure. The session highlighted the EV charging infrastructure, which includes charging stations with AC charging and DC fast charging, using power electronic converters and smart chargers for load management and grid coordination, enabling reliable and large-scale EV adoption. With these upgraded understanding, we shall now move on toward session 9 of Day 5. At this moment, I kindly invite Mrs. K.S. Margaret to introduce our esteemed guest for the session.
Honorable guest, Mr. S.V. Sriraj, ME Electronics and Drives. Welcome, sir. His experience to note, he has worked as a design engineer. He has started his career in the year 2008 at Honeywell Automation India Limited, and he has worked as a development engineer in top system from 2013 to 2014. He has also worked as an assistant professor from the year 2014 to 18 in Sri Venkateshwara College of Engineering, and now he works as a director, technical and operations, MCOM Solutions. He is also an efficient program mentor in IntelliPart and a franchise partner of ANSYS Consulting. He has got 13 years of professional competencies, major projects and credentials. He has worked with IIT Madras Chemical Engineering in developing a DC-DC low voltage using Raspberry Pi and IoT devices. His other clients are CBR and ARA, where he has worked with aircraft, GCU electronics design. He has also worked in education and organizations as a technical expertise, and his areas are system design modeling, EV cells battery, testing EV cells to verify capacity and performance characteristics, interfacing EV cells with smart BMS and configurable systems, battery development and testing, EV powertrain testing and mid-drives, fundamentals in MATLAB scripting and signaling, HMI development for EV systems for plotting real-time characteristics, embedded system programming in RISC and ARM architectures. He has achieved and published and received appreciations. To make few things to note on, he has received appreciation letter from IIT Madras for low voltage booster converter design, fabrication and testing. He has received appreciation from Project Manager Group for delivering quality handball engineering solution for US Naval Academy in the year 2009. He has authored and published interactive books on MODERNISING programming, which helps rural students to learn coding and develop application of new technologies. He has got certification as a lead auditor from CQI, IRCA for ISO 9001-2015 and ISO 21001-2018. He is certified in solar PV plant system designed by Global Sustainable Energy Solutions, franchise unit of GSES Australia. He is certified in e-vehicle system development MSME. He is an executive postgraduate certificate program. He has received an executive postgraduate certificate program in e-vehicle design, certificate by IIT Roorkee Mathworks. He has trained around 10,000 students and professionals in power electronics and embedded system. Thank you, sir. Once again, welcome for the session. Thank you.
Thank you, ma'am, for the clear and informative introduction of our distinguished guest. Now, it's my great pleasure to invite Mr. S.V. Sriraj to kindly take over the session and enlighten with us.
Good afternoon, all. Hope everyone is so active. Right? So it's very difficult to have a theoretical session, especially in the afternoon. So I know very well because I have been as an audience as well as a trainer so many times. So, but the topic, we have to do two things today. One is that we are into this topic for some time, and then I would like to give you a hands-on in battery pack and battery management system, how to interface battery pack with battery management system and get data in your hand. Okay, something like that we do. But before I go into this session is very easy to tell. We can interface wind and PV for electrical vehicle charging equipment. But the problem is that we have to address few things before this. Coming into integration, before addressing integration, I have to ask you a few questions. And we have to ensure that we are very clear with those technical issues, and then we'll come back to see how we can integrate with. Okay, so these are the points of discussion, and I would like to get answers from you participants. So let's go with the first question. Why lead acid battery is not recommended for EV?
Low power density.
Low power density. Okay. Then
Less available in markets.
More bulkier.
more bulky. Size, in terms of size, it is bulky. Okay.
Availability issue.
Availability. Okay, if I am compromised with the bulk size, then what is the problem? Okay, let's say I am compromised with that. Is there any major issue? Okay, no, in terms of efficiency, in terms of weight, because as you said rightly, the weight is huge, it will act on the total weight of the vehicle, gross weight of the vehicle will increase. That's agree. But which parameter or which factor?
More time to charge.
More time to?
Charge.
Okay, fine. So, which parameter decides or tells we need to keep lead acid battery away from EV? Which technical parameter of battery chemistry?
Low nominal voltage.
Low.
Nominal voltage.
Now, nominal voltage can increase, right? So let's say you have a 12 volt battery, if you put it in DC, is it 24?
That's okay, but
No discharge.
for a single
Discharge.
If you go for lithium, it will give you a 3.2. So
No, if you look at lead acid, the battery which we use at our home is a 12 volt battery. Correct. So if you see 24, you could have seen 24 volt system, you would have seen 60 volt system, 72, 108 volt, 120 volt. All these we use in lead acid also.
No charge and discharge.
That means number of cells will increase.
Of course.
The same capacity.
Correct.
compared to lithium.
Correct. The number of cells will increase, the size will increase.
That will increase the cost, weight.
Fine. But what is the technical parameter? Can somebody capture it?
No discharge.
Number of cycles.
That decides the longevity of the battery. So all these things come after implementation of battery. If you give me a battery and say no, instantly, which factor pushes me to tell that?
Discharge. No discharge. No discharge.
Low discharge?
For charges.
Okay. We'll come back to that. But there are very good answers amidst good responses. Let's go into the next question. What feature in lithium chemistry permit us to use it?
High energy density.
High energy density, compact, lightweight. Very good. Third, what is C rating? Suppose you see a cell, 1C grade, 2C grade, 3C grade.
Charge.
What does it mean?
Charge per time. That is how fast is charges per unit of time.
Charge,
That is based on SOC. It is
Charge discharge 1 CV for 60 minutes.
let us say, can we use this board?
how much current?
any cell, do you want to see? Should I show any cell of 1C to on the display? Okay, let me show you. But if you look at any battery or even single cell, we are not talking about battery. Battery is nothing but when you combine cells. Let's talk in terms of cell. Many cells you could see 1C, 2C and 3C. And I've seen 5C also, but let's talk about 1C, 2C, 3C. So what do you mean by these C numbers? Because why I want to tell you all these things? We normally believe that when I keep my vehicle nearby a fast charging station, it means that the battery is charged so fast. It is not so at all. Because the charging speed should not be decided by the charger. It should be decided by the battery, right? So if you show me unlimited meals here, the meals should not control me. I should control the meals, right? So how much I can take, I'll take it. So if I want to know my capability, I need to know all these factors. So if you look at 1C, 2C, let's say if I buy a cell, then can I type some? Okay. So can you type LFP 3.6 volt or 3.2 volt, comma 6AH 1C, 1C or 2C, whatever it is. LFP 32700. 32700. Okay, I'll show you the picture, but let's come back here. 1C, 2C, 3C. I buy a cell, let's say 3.2 volt 6AH, and in the spec of the cell, you can see the blue color wrapper over there, right? Here normally we mention 1C and sometimes 2C and 3C. Okay, so let's say if I buy 1C cell, what does it mean?
Can answer 6 amperes current or 60 means?
Okay. 1C means C. What is C? What is H? That is also cool, right? Ampere hour means current into time. A into H, current into time is charge. Unit of charge is cool. So if I say 1C, it means 6 amps. Okay, now here there is a question. Question is that on the wrapper you can see 1C. Now I will confused when I made my first battery whether this 1C is for charging rate or discharging rate. So that means whether the manufacturer is telling me that whether I can give 6 amps to charge the cell or whether I can take 6 amps from the cell. So here is what our doubt.
Both, sir. Both.
No. See, whatever the C rating we write or you usually see on the sticker is meant only for discharge. Normally you cannot charge at 1C, 2C, 3C. Okay. So how do I know this? Okay, let's say if I say this is 1C and says that 6 amp you can maximum discharge from this cell because it's a 1C rating, then tell me what is the charging rate for this cell. How do I identify it? Okay, so for that, normally we have to refer the data sheet of this particular image. In the image, even I will show you, maybe during the hands-on also I will show you. Let me take one typical data sheet and I will clarify. They specify separate charging rate and separate discharging rate. Okay, on the sticker, whatever the C rating you see is not for charging, it is only for discharge. Suppose if you are not able to find the charging rate in the data sheet, you need to assume or you should assume your charging should be 0.2C to 0.3C. Don't give more than that. Okay? Is it clear? So I come back again. The C rating which you see on the sticker, okay, is for discharging rate, not for charging rate. But if I want to know what is the charging rate, I have to refer the data sheet. If the data sheet is not specified or you are not able to get the data sheet, sometimes we buy from China, after getting the result, the people will tell that there is no data sheet at all. So what we have to do, we have to take a thumb rule saying that 0.2C to 0.3C is the top. You can test it. If you want, you can test it with higher C rating also. I have tested up to 0.5C also for some cells. But you have to use testing for many cells, many number of times to come to a conclusion. Now coming back to the first question, why lead acid battery is not recommended for EV? The simple reason is that, can anyone tell me what is the C rating of a typical lead acid battery? What is a typical C rating number for lead acid? Normally C rating of lead acid is 0.1C. Okay, let us take one case. I buy a two-wheeler and this two-wheeler needs 1.5 kilowatt power at 48. If so, what will be the current? What is the current need? It's around 32 amps or let's say 35 amps, approximately 35 amps. Okay, so if I want to get 35 amps from this guy, lead acid, what should be the age of the battery size? Ideal age. What should be the ideal age of the battery size or battery pack? The C rating is 0.1C. Yeah. So you have to buy 348 volt, 350 Ah in order to get 35 amps. Right? But I can get it even from lithium. If it is a 3C, I can even buy 48 volt. Any guess? Even I can run with 12 Ah battery. Because 12 into 3 is 36. You need that. But backup time, let's not worry about backup time. Okay, let's not worry about backup time. But you can see this lithium is very fast in the sense that it is able to run or able to deliver more current at any point of time compared to lead acid. So that's the reason we can use lead acid in electric vehicles. There is nothing wrong. But the problem is that whether the cell or the battery pack has the high C rating so that it can deliver more current instantly, so that your motor can run. Okay, so you can make any, even if you invent any battery or any battery chemistry, the thing you have to think about in a commercial perspective is the C rating of the particular chemistry. The C rating is convinced, then we can have any chemistry in this country to run an electric bike or electric vehicle. Okay, so this is one thing which is very important when you try to build a battery pack for your, or when you choose a battery pack for your vehicles. Now, so I hope the first is clear. The second question is also clear. Third is also clear. Fourth, how do you identify max discharging current from the battery? From the C rating, you can identify the max discharging current. How to identify the max charging current to the battery? You have to refer the data sheet. Otherwise, go with this thumb rule of 0.2 to 0.3. Last question. While charging, how electric vehicle supply equipment, that is your charging station, EVSE, knows your battery current requirements. So that means you are taking your battery pack to a charging station. Okay? The charging station is common. It is for all the vehicles. But when you bring your vehicle, I may have a different battery chemistry. I may have a different battery, not chemistry, even battery rating, probably. How my EVSE can understand this is what my requirement is. Because charger says, what is the role of charger? Charger can give current. But charger doesn't give current, the battery doesn't need. Right, so how this happens? I'll repeat, when you take a vehicle to nearby to your EVSE, how EVSE understand your vehicle battery requirements. Any idea? So, if you look at your charger, okay, which you plug into the vehicle, do you think that the charger has only the port for giving current to the battery? Let's say this is my charger, okay, charging station. This is my battery. I am hooking up the connector and plugging it. Do you think that this connector only have the port for sending power?
No, even for power to grid.
In-
Power to grid also.
No, let's forget about the grid. So I have my battery here. Okay, so I am taking the connector from the charging station and connecting into the battery. But this charging station is a common thing for many vehicles. But this is my battery. It has different capacity, something like that. Maybe it is made up of different requirements. The current requirement of this battery pack is different. My question is that when you take the connector and plug into the battery, how this charger knows what this battery exactly needs, how much current the battery exactly needs. But this information is needed.
BMS.
Yes, BMS is there, but again, how this connector, if you look at the connector ports, hope you have studied in the architecture of EV. Let me show you here. So if you look at this bar, the DC001 we just introduced, but right now we are using what CCS2, combined charging station 2. And if you look at the combined charging station, you have 1, 2. This is DC charging pins. Okay, and you have 3-phase AC, 1, 2, 3, and neutral. Okay, and then you have the earth to protect the earth. And other than that, you can see 2 pins. Okay. One is called control point, okay, which actually communicates with your battery pack. There are 2 pins. One look at whether the charger fits properly or not, proximity, and another is called control pin, control point. Basically, the control point, when you connect to the battery, it communicates with the battery. Okay, so that's how, through that CP point, the charger comes to know the requirements of battery. So it doesn't mean that the charging connector has only power ports. It has a DC and AC power ports. Apart from that, there is a proximity pin, whether to check whether the charge connector is fixed properly, and one more pin which communicates with your battery. Okay. And that pin is called control point, control pilot. It's control pilot, not control point. It's control pilot. Now, what are the different ways it communicates? So, as you said, CAN is one way of communicating, but there are many different ways here it communicates. That depends upon the charger. If you look at the AC charger, we use a very small, very cheap method. This is called PW method. It's a very interesting method. Normally people think that we have to send some data from CAN or you have to get data from Wi-Fi, you have to take the data from Bluetooth. It is not needed at all. There is some technique called PWM technique. Through that PWM technique, the charger will understand what is exactly the battery needs. There is one way. I will show you what are the different PWM signals, how they interpret each other. And second thing, we have PLC. Have you studied PLC communication? Not the programmable logic controller. It is called power line communication. Okay, power line communication. This is one method. Whether the cable, the power cable itself will act as a communication cable. And another one, we have CAN. So there are 3 ways. Not only one way we are communicating, I mean the EVSE is communicating with the battery. There are 3 ways that EVSE can communicate with the battery. Okay, so one is PWM, that is the most cheap method, and normally why people work with PWM, because the reason is that PWM is not affected by EMI EMC. When you send some communication signals, say low signals, what happens? It is easily affected by EMI EMC. But PWM signals are not, because it's carried little power. So that's the reason it is not affected much. So we use PWM technique in communicating. Okay, so this is the TWM method, where if suppose the EVSE is setting 12 volt, okay, and it EVSE sees, not send, if EVSE sees 12 volt at the control pin CP point, then it means that no EV is connected to the EVSE. If the control point voltage, control pilot voltage, CP point voltage is 9 volt, then EV is connected to EVSE. So this is how the communication between the battery and the charger happens. By looking at the voltage of CP point, the charger will understand whether the charger gets connected with the battery, whether the battery is ready for charging. Okay, but in this method, the problem is that the battery cannot tell charger, send me this amount of current. That communication will not happen in this model. Only the battery can intimate with the charger saying that, okay, I am ready. The connection is successful. You send me current. Okay. Only these informations can be done. But send me this amount of current. Send me 10 amps of current. Send me 20 amps of current. This information cannot happen through PWM. But is there any issue? Or in which type of charger this method is very useful? Anyone? Whether it's AC charging or DC charging. Hope you know the difference between AC charging and DC charging.
This is the first.
No, DC charging directly from the EVSE, it goes into the battery. Okay? There your BMS will communicate with the EVSE. Okay, but in this case, it is for AC charging. In AC charging, you know that there is an onboard charger on the vehicle. So we will take this connector, connect to the vehicle. Inside vehicle you have an onboard charger. Onboard charger is nothing but AC to DC conversion. Okay, suppose my charger is saying, let's say, this is my EVSE. EVSE has a capacity of 100 amps. That means your charging station. Okay, charging station has a capacity of 100 amps. Now you are connecting to a battery. You are connecting to a battery via your onboard charger. Okay, because I know you have already done about onboard charger. That's the reason I am just bypassing all those things. So let's say you are connecting to your battery via onboard charger. So this is your onboard charger. Assume onboard charger. Okay, and EVSE says that I have 100 amps in my hand. Okay, I have 100 amps in my hand, but the battery needs only 20 amps. Let's say. Now, how only 20 amps will go into the battery? Because in this communication, you can't see anywhere the battery is requesting a magnitude of current with EVSE. It is just saying, okay, you are connected to me, I am connected with you, so successful and so on. All these normal messages. But it never requested the EVSE to send, okay, 10 amps of current, I am ready to take 10 amps, I am ready to take 20 amps. So this communication never happened. So in this case, let's say if I have an EVSE of 100 amps capacity, this guy says that I can give you 100 amps, please take 100 amps. But this guy says, no, I cannot take 100 amps, I can take only 20 amps. So now, how this current is regulated? So this current is regulated because of this onboard charger. Onboard charger will take care of it. But in case of DC charging, you don't have an onboard charger. Correct? So in that case, the BMS will communicate with the EVs. So here you need CAN communication or you need PLC communication. So PWM don't work here. Okay. So I just want you to convey that how EVSE communicates with battery. Why EVSE wants to communicate with the battery? Because the battery wants to talk to EVSE. Why it wants to talk to EVSE? Because battery wants to tell its requirement to the EVSE. Okay, EVSE should not think that, okay, I have 200 amps, I am very rich, I will give you all 200 amps to you. But the battery is not ready to take it. So it has to communicate at some certain level of point. So we need this communication points or ports to communicate with the different topologies. One topology is PW, one is PLC, one is. So there are so much information. I will pass this in maybe PDF. You can note it later. Then we can think it. You can. So why renewable energy integration is needed? What is your point? Why we need to integrate renewable energy in for EV charging? Complete? Okay. Do you think renewable energy is green? I worked in a company called Top System in Gumudi in 2013, where we make solar panels. Basically, we take the old panels from Germany, we clean it, and then we resupply it. You can't see in that place, you can't see any dog with skin, because we do acid washing. Actually, it is not, see, the way the solar panel is manufactured is not accountable. When it comes for utilization, okay, you can see we are not burning coal every day, right? But making process is not green at all. It's for out of box, right? So the first thing that EV, as you said, it's renewable energy. We can go for renewable energy source. Fantastic. Any other reason?
Charge engineers.
Less cost. Capital is good, very huge capital, but running cost is less. Okay.
Charge engineers.
Charge.
Engineers.
Okay. So how much unit of energy you will get if you install 1 kilowatt of solar? Let's say I have 1 kilowatt of panel, solar panel, or 250 watts 4 panels. You can take any way, or 500 watts 2 panels. If I install on my roof, how much energy, units of energy, in terms of kWh, how much I get? Anyone?
10%.
Sir?
10%.
In terms of kWh, how much? And whenever we talk with battery is an energy storage. Energy storage is units of energy. For example, in your Ola scooter, Ola scooter needs around 3 to 4 units, correct? Or a battery size. 3 to 4 units. So assume it's 4 units for if I want to get 4 units of energy, how much solar I have to install? Good.
You get around 8 units of kilowatt.
Okay. So the thumb rule is 1 kilowatt will give you 4 units. 4 units. Max. Okay. Not max, it's an average. When I installed to a customer, I got in Chennai, Saligramam place, I got around, in the first few days of installation, it is really good. Around first 3 months, I got around 5 units, even some days I got 5 units per day. But when we tell the customer, we promise the customer, we don't tell 5 units, we'll tell only 4 units per day. So at an average, you get 4 units per day. So that means in order to run your vehicle with full energy, full loaded energy every day, you can install only 1 kilowatt is sufficient. 1 kilowatt cost now comes around, cost is reduced 60,000 rupees, 60k to 50 to 60k. So only 50k to 60k is highly enough given to power up your vehicle every day with 4 units of energy. Now what are the possibilities we have? How can I connect my solar panel into the battery? What are the different configuration of solar? Can anyone tell me? What are different configuration of solar? What are the different configuration of solar? What are different ways I can connect the solar? So what is this mode? there are two modes or two configurations. What are they? One is on grid, off grid. Okay. So let's say if you take on grid, what is on grid? Connect the existing power to grid. Okay. So that means your solar panel is connected to the inverter, and an inverter will power your load. Okay. So whenever you're not using or you have excess of energy produced, you can send that energy to the grid. Now what you can do? Instead of sending energy to the grid, you have your vehicle. Okay? Yeah. So it sends through net meter. If you want, in this configuration, you can, instead of sending to the grid, you can take it for charge. Because you have an onboard charger in your vehicle, so you can plug into. So this is one possibility we have with on-grid system. In off-grid, what is off-grid? Correct. In off-grid, what we do, we don't send to the grid. We'll store in the battery. Okay. And then this DC you can transfer to or give to your vehicle. Okay. So the possibilities what we can look at solar is that unwanted, because when I go to external or public charging station, they are charging around 10 rupees to 13 rupees depending upon the demand. The time after 4 p.m. it is 13 rupees. Before 4 p.m. it is 10 rupees. So instead of that, you can, if you have solar, without giving to the grid, if you give grid, you will get 3 rupees. Okay, if you send to the grid, you will get 3 rupees. Why you are wasting your money? Because if you want to charge it at 10 rupees, you are giving government for 3 rupees. Why can't you use it? So that's the idea of why you want to integrate solar into EV. So there are many ways. So all these are some ideas. I want to give you some ideas of, in terms of designing, in terms of system configuration. There are many possibilities. And that is also possible. We have even you have seen. I'll show you one company, GoSun. There we have two possibilities. Even my first picture you have seen, the introduction picture. Or let me show you. See that net connected? Can click on the link. Top level. Issues suppose running I'm going to connect solar into the battery, directly to my battery. Do you think any problems in that? Okay, if you look at this, look at here, this vehicle, is it not running or sitting idle? Now, it is on idle. So this is around, I think, 450 watt panel completely. But I cannot use these fours, right? Only one panel I can use, which is on the top. That is around 150 watts or 200 watts max. So that means on the running, I can use only 200 watts. But do you think, is there a technical issue if I use the single panel and charge my car battery directly? Do you find any issues? Yes. Okay. Because the problem is that there should be some minimum current. Otherwise, the onboard charger will not allow that. So what will happen when very small amount of current flows? The onboard charger will not allow that current. So what we normally do in this particular company, they have a battery, separate battery, and they charge to that battery, and that battery you can use it for charging the car. So that the intermittent power problems, power interruption problems directly when you connect solar, all these will be addressed. So that's the reason people use an auxiliary battery, and that auxiliary battery will be charged by the solar panel. And from the auxiliary battery you can charge your traction motor. This is how this company has addressed this issue. Go back. And another point when somebody is doing research in solar powered EV, you have to think about there's some concept called MPPT. You might have done already, right? Maximum power point tracking. So maximum power point tracking is simply you need to track the maximum power which is given by the panel at that time. Why we need to know that? Why it is so important? Because when I connect my RPS, do you do maximum power point tracking to get the maximum power to your load? When you connect my battery to the load, do you do the maximum power point tracking? No, we don't do that. But why, especially in solar, we should do that? I'll repeat my question. Suppose I'm going to charge my battery through another battery. I never talk about maximum power point tracking. If I connect with another, let's say RPS, power supply, any other power supply, X power supply, DC power supply, I never talk with MPPT. But only for solar, why should I talk for MPPT? Yes, because it's power curve, what you have seen, probably you have seen the power curve. Right? You can see the PD curve. Okay. This is not flat. Okay, you can see the maximum power only on one top corner, right? The top corner only the maximum power is available. If suppose my curve is flat, then I don't talk about MPPT, because whatever the power which is given by the source is maximum. There is no doubt at all. But for in this case, you could see the maximum power is only on the top. The curve is going like this. So coming to the how we can integrate. Okay, how we can integrate solar. I will show you a company called. Can you click on that link? Data sheet. Victron Energy. Victron Energy has now introduced in the last exhibition happened in Expo happened in Hyderabad. They introduced this particular charger. Here you can connect solar. And I'll tell you how this is done. Can you go back to the PPT? If you look at here, this is your solar panel and this is your inverter. Okay, this is solar inverter and this is your charger cum inverter. And the red and black color is nothing but DC line. Okay, and this is AC line. So that means your solar panel can be converted into AC, DC to AC, and you can connect to this line. This is your AC line. And if you want, you can connect this to your EVAC. And repeat, you have a solar panel. This is the solar inverter, and this converts. You get AC. And from this AC, this is your charging station. From this AC, you can connect it and charge your vehicle. Okay. Otherwise, you can take this AC and convert it to DC, and then store it to your battery. Okay. And then if you want to take power from the battery, you can again take it from the battery and do the inversion, and then this AC out can be converted to charging station. So that means the input side of the charger you can connect EVSC, output side also you can connect EVSC. But you may have a question, sir, in this case the solar is intermittent. So the power, AC power at this point may fluctuate. Okay, so what they do, they monitor this line. Suppose if this line has an intermittent problem, you have already stored some energy here. So that will be converted to AC, and this particular AC line will be maintained with proper energy. So look at here. This is a very complex network. No problem, I'll manage. No issue. This is your solar panel, and this is the solar inverter. And this red and black is nothing but DC, because solar is DC. So you get DC input. And this inverter converts DC to AC, and this AC comes here. But the problem with this AC is, if the solar input is varied, this particular output will also vary. So if the solar output is varying because of shadow, right? For shadow will be the you can have pakkatla or very vehicle go. So what happens? There will be less power. So this part, this AC line will have less power. But as I told that, there is a problem with EVSC. Okay, EVSC cannot charge this vehicle if this power is less. So what Victron has done, Victron also have some battery, auxiliary battery. Okay, and energy will be stored in auxiliary battery. If suppose this line is fluctuating, then from this battery it takes the DC input and converts it to AC. So this particular AC line can be maintained, the power can be stabilized. So in this way, we can integrate solar practically for EVs. Okay, so here what you do, you don't sell to grid, because when you sell to grid you get 3 rupees. And when you do charging, let's say if you want to go for a semi-public charging, or you want to set up your own charging station, then you can do this. You can install solar, okay? Don't give the excess power, take the power and store in the battery, and then give to your EVs.
EVSC is AC, sir.
Which one is that?
EVSC is taking power.
AC.
Is that is frequency issue? Because you connect to AC lines.
No, see, you are converting from the inverter, right?
So inverter doing some AC from some frequency.
No, inverter. See, normally all these are synchronized. All are synchronized into the AC. No, normally see when you take a solar, okay, solar is giving you pure DC, and when you do the inverter, you are only controlling the frequency, right? I mean, in the program, whatever we write to develop the inverter.
That's what when you connect from grid to there are some multiple AC charges.
No, one from the solar, okay, one from the battery. So solar is also DC, battery is also DC.
From that you are going to inverter and you will take it to line.
Correct.
And again you are feeding to another AC.
EVs.
EV.
Correct.
AC, right?
Yeah.
So that AC inside that EVSC, the frequency would be matching.
No, EVSC, see, EVSC, whatever the frequency EVSC needs. Because EVSC is what's sitting in the AC line. Correct. In the common AC line, EVSC is only sitting. Correct. You can see 2 EVSC on the same AC line. So that means the frequency coming to that line, okay, is designed to match with the EVSC requirement. Even not only frequency, all the parameters which you convert into, let's say harmonics, not let us talk about harmonics also, THP. The THP also we have to control and maintain the THP on the AC line with respect to the EVSC requirement, because EVSC is all sitting on the line.
That's what I'm asking. There is some harmony. Is that the specific frequency
of 3% to 5% is accepted. So whenever we design inverter, we maintain it.
It's not that kind of fluctuation in it because normally even that is not there. So we use the fluctuation.
The grid fluctuation also, if you look at the frequency, 49.2, 50.5 is the allowed frequency. Even the allowed frequency. It is not a issue there.
That's what it means. Sometimes even a term out, some apply the fluctuation in there.
The fluctuation, normally the frequency fluctuation as per the government requirement is 49.58, I believe 49.2 to 50.5, something it is allowed. But more fluctuation you will get on the voltage, right? Voltage fluctuation you will get it. Okay. Now EVSE will have to maintain, because whenever we do the EVSE has a PFC stage, initial stage. Okay, so that also it will take care of. But I don't think so that the frequency is going to vary, because as I said, that particular line where EVSE is only taking current from the AC line, the power is given in such a way that to meet the EVSE.
So we need to charge a vehicle on board, right? Like how we have a stabilizer, it's something as equal to the
No, see, we have, whenever even in the product itself, we have over voltage measurement. Okay, so let's say I want to convert into DC. Okay, let's say AC to DC. I will not operate if the AC voltage goes above certain limit. Even if you look at your UPS, above 270, they will trip it. So even that state we include on the design itself. Okay. And second thing, we also think about the load side. Nature of the load should affect the nature of the current. So that's the reason we do PFC. PFC is the input state itself, not at the output state. Even at the input state itself, we will try to maintain the PFC.
So when you connect it for DC charge, if you convert a DC to DC and charge the vehicle. So we have to do some filter characterization.
Filter characterization means the DC power
Will not affect the charge because it will affect the charge of the
correct. So see, normally, sir, if you look at in all the designs, even not only EVS, if you take small SLPS also, current ripple normally we give 30%. 30% is allowed, 30 to 40% is allowed. Why current ripple must be allowed? Because current ripple is something which, suppose the load is changing quickly, the power converter should respond, right? So that's the reason normally we give a current ripple of 30 to 40% must be allowed. Voltage ripple as a standard we maintain 5%. Then only you can, when you go for certification for BIS standard. No, all the products they give 40. 40%, 40 is allowed. 40 should be allowed. Otherwise, you cannot meet the sudden change in the load requirements. So, for example, you are connected 10 lengths. Immediately you are connected 20 lengths. If the current ripple is less, then the converter cannot give sufficient power to the load. The voltage will come down quickly. So, in all the design, current ripple is 30 to 40% is allowed. But voltage ripple normally less than 5%. If you meet this requirement, then only even we can pass the BAS, highest standard. Okay, any other questions, sir?
So how we support the battery? Cannot program for
No. Because see, even in our house also, even why do we allow on grid? So what is on grid? On grid is very simple. You take the solar power mixing with your line. Your house line is already getting a grid power. Correct. Now, in solar, what you do? You convert DC to AC and mix with your grid. Why you want to mix with the grid? Because you want to run AC, you want to run all the loads without any interruption, right? So that's the reason we do on grid. But why it is called on grid? Because the reason is that it's very, very difficult. Because let's say this is my grid. The grid is now going like this, assume. The grid power is going like this. Okay? I am going to inject my solar power, which is converted to AC, at this moment, let's say. At this moment. That AC assume AC is moving. Now you want to inject at this moment, in the instant, you want to inject this solar power here. You inject in the point, every synchronous arm. Suppose if you give this point here, the net power will reduce. This is what it is done very beautifully by the on-grid inverter. And the on-grid inverter was a cost romba jaasti. That is the reason it has got the name on-grid. Off-grid another, current போயிடுச்சுனா நீங்க அப்பதான் இத ஆன் பண்ணுவீங்க. So அது எந்த எப்படி இருந்தாலும் பிரச்சனை இல்ல. 50 Hz இருக்கு அவ்வளவுதான். We are not worried about this instant because we are not matching with the grid. But when we mix with the grid, it's very difficult. You need to match with the grid instant pace. Otherwise your net power will go, vector power will go less. Where are the questions irukka? If not, we will continue the BMS hands-on. But BMS hands-on munadi, I want to explain you why we need BMS. Without BMS, what happens? And how do we connect BMS to the battery? அதுக்கு முன்னாடி இதுல ஏதாவது questions இருந்துச்சுன்னா you can ask. Solar powered எல்லாமே demo vehicles தான் இருக்கு சார் வரைக்கும். But on gridல power mix பண்ணி we are taking from grid, that is happening. But அது ஒரு புது டெக்னாலஜில கிடையாது. So old technology. I'll do a small summary of what we have done. We have done a very small thing only, but I hope you got some good information. So first thing we understood how to identify a cell, how to identify this, why the C rating is so important, why we ignore lithium, why we ignore lead acid, why we give more importance to lithium. And second thing, we also learned about what is the, how to decide the maximum charging current, how to decide, how do I know as an engineer, how to find what is the maximum charging current, what is the maximum discharging current for a given battery, right? And then we have seen MPPT. We have also seen, normally people say fast charging, but remember that the battery should decide the charging current, not the EVSE. If the charging station says that 100 amps, I can give 100 amps, the battery should accept it. That means there should be a communication between the EVSE and the battery. How that communication happens? The communication happens in three ways. One is via PWM in AC charges, level 1 and level 2 charges. And in DC charges, we have two options. Go with the PWM mode or with CAN. Okay, so these are the two options we have. And then we have seen into solar, we understood how much solar is needed in order to charge a 4 unit of battery pack. We need only 1 kilowatt, the investment could be around 50 to 60K. And what are the ways to charge? But I have not referred any research paper. I have just given you the commercial product, what is available in the market today. So that is what the last architecture what I have shown. It's from Victron Energy. Hopefully, if you want my slides, you can take slides. And there is a link. You can go through the spec of the inverter. Fine. So I think that's all about this topic. But I would like to, if you want any break for you want a break? Okay. We'll take a 5-minute break, short break, and then we'll continue the chart work for BMS. We'll understand how to interface battery and BMS, and then we'll see how to do practice.